experiment related to natural product chemistry. In other words, you have plants or animals, you want to extract some compounds of biological interest. So you extract those compounds using certain procedures. So today we are using a simple procedure of a natural product that is going to be extracted with the help of a solvent, dichloromethane. Okay? So what we do is basically we're going to extract caffeine. This is the molecular formula for caffeine. As you can see, the middle part of the structure is actually the purine molecule. Purine molecule can be found in DNA, nucleic acids, RNA, DNA, etc. But it can be found in many other natural products called they're called nitrogen bases or alkalides. They are basically basic compounds. They are because they have nitrogen. Nitrogen is basic. So anyway, so when we extracting caffeine can be found in tea as well as in coffee and many other plants as well. Today we'll be extracting caffeine from tea because caffeine is the active ingredient in the tea leaves. So we'll be using 4 tea bags and we will be boiling them in 75 ml water. Before we do that, we have to find out the mass of the tea leaves in each tea bag. So tea bag you have to actually rip it open and determine the mass of the tea leaves so that you know how much tea leaves are present in each bag. So you multiply it by 4, you will be getting the overall quantity of tea bags in 4 tea bags. Overall quantity of tea leaves in tea bags. Anyway, so we'll be boiling it in 75 ml, boiling tea bag in 75 ml of boiling water. And it's just how you prepare tea basically. Caffeine is soluble in hot water. It's not very soluble in cold water. So you have to boil it. Okay? After boiling, you basically cool it. And after cooling, you have to start working up. Working up is a procedure by which you have completed the experiment. Now you are trying to extract the desired product. Okay, so caffeine is not the only thing that's present in the tea leaves. There are some acidic compounds called tannins. So your tannins are acidic compounds, and caffeine is a basic compound. So you have acid and base in the same tea leaves, So you have to actually use its white base, sodium carbonate. We use sodium carbonate. So we add sodium carbonate to neutralize the tannins, which are acidic compounds. Okay? So those they go in water as well, but they will not be extracted by DCM. DCM will extract only your caffeine, and it will leave the tannin salts inside water. Okay? All right. So once we have treated with sodium carbonate and we have neutralized all the tannins, and now we add DCM to it, and we shake it in separatory funnel. I'll show you how to do that, and we extract. The caffeine will be distributed between water and DCM. So it is more soluble in DCM than in water, so more of it will go into DCM layer. We extract those 2 layers and separate them together and drain the lower layer, which is the DCM layer, heavier than water. It will have caffeine in there. That's called first extraction. Then you add more DCM and you extract it again. So you do 2 or 3 extractions. I require my students to do 2 extractions at least. We combine the extractions and then we get rid of the DCM. The way to do that is distill off DCM. DCM has a low boiling point, so it can be easily distilled off. Your caffeine will not be distilled off. It's a high boiling compound. Now, after you remove the DCM, you will get a white mass. That white mass is caffeine. Caffeine is actually a solid compound. So you find out the mass of that, and you know the mass of total leaves, and you know the mass of your extracted product, and you find out the percentage recovery. So that means how much caffeine you have been able to extract, and you can compare it with the literature data. So, okay, so this is enough, and we'll go to the lab and we'll start extracting the
This lab is just about making tea that you make at home. You take a tea bag, you remove the thread and the label, and put in boiling water, and uh, put three of them. Make sure you know the mass of each bag, and after that you cover the beaker with a watch glass. All right, we have been actually boiling the three tea bags in water for about 15 minutes, and we assume that all the caffeine has been extracted from the tea bags. All we got to do is now remove the tea bags from the tea preparation. But before you do that, realize that all tea bags have quite a bit of caffeine in there too. So we want to extract those. Now either you can squeeze them with between the two fingers, between the thumb and the fingers into the beaker, or you can use these two watch glasses. Put the bag in between the watch glasses, sandwich them, and then press them together. And that way, that's the safest way of um, extracting the tea solution. Do the same thing with all the other two bags as well. Alright, so you assume that all the caffeine or all the tea has been prepared and the caffeine has been extracted already, and all you got to do is now cool the beaker to room temperature. The best way actually to do is cool it in ice water mixture, only not to 0 degree, only to room temperature. So take some ice water mixture in a beaker and put this beaker containing the solution and to cool it to room temperature. Now this is a dichloromethane. It's also called methylene chloride. This is the solvent that you'll be extracting your caffeine with. So after waiting for several minutes, I can see that most of the separation has occurred, but I see lower layer, clear lower layer, and a dark upper layer. Dark upper layer is aqueous phase, and the lower is DCM, dichloromethane phase. And your caffeine is in the DCM layer. And now you can see some bubbles over there. Now this is called emulsion, and emulsion can be very troublesome. People do different sort of things to get rid of the emulsion, to get rid of the emulsions. Sometimes people use glass rod. They do circular motion at the interface where the bubbles are. So you break the bubbles with the glass rod. Sometimes swirling helps, and once you have whatever you can do, then you do your best and let the layer separate. And then you drain off the lower layer. Remember, lower layer is the DCM layer that has your caffeine in it. The upper layer has a lot of other junk in there that we are not concerned with that. So you can actually drain the lower layer till the foam. When you get to the foam, you can arrest it. Okay, don't add foam to your beaker. Okay, so this is your extraction. Okay, this is the first extraction. Now you are going to have the second extraction. Now you add 15 ml more of DCM. You already added 15 ml for the first time. We add 15 ml more, and you do the same thing. Make sure you don't shake it at all. You just basically swirl it. Not either swirl it or upside down, right? Put it down, and do that like 15 times slowly. Make sure you do it slowly. Don't shake it, and then you put it back on the ring stand and remove the stopper, and now wait till the layers separate. Again, you can see bad emulsions over there. Now you can use the same thing, just same technique that you did before. You use glass rod to break the bubbles. Okay, you can use circular motion to make sure you break the bubbles. It helps actually, and swirling also helps, and agitation with the glass rod certainly helps, as you can see. Okay, so now you are ready to drain the lower layer. Remember, lower layer is also has your caffeine in it. So this is your second extraction. You can combine it with the second, combine it with the first extraction. So two extractions. Now the third extraction, again with 15 ml of DCM. You add DCM and repeat the entire process again, and now basically your separatory funnel up and down, and after that use swirling and glass rod to agitate and break the bubbles and drain off the third layer, and combine all these three extracts into the same beaker. Okay, now there are three extracts over there. There might be some moisture in there too, and we will get rid of it by adding anhydrous sodium sulfate to it. Okay, now we add sodium sulfate, anhydrous sodium sulfate to it, and we leave the DCM extract on or over the sodium sulfate for about 5 to 10 minutes, or you can actually speed it up the drying process. Anhydrous sodium sulfate dries, it removes moisture from the DCM, and that's what we are doing actually. So now you see DCM layer is quite clear, and that's good. Now we can actually evaporate DCM from it. So remember, we collected about 1245 ml, 3 combined extractions of caffeine. I have transferred those caffeine extractions into a round bottom flask. I'm using simple distillation that I'm familiar with from your first experiment. So this is a round bottom flask fitted with a 3-way connector and a thermometer and thermometer adapter and the condenser, and you are actually collecting the distillate. So it will take about 15 minutes to completely distill off DCM. Okay, now most of the DCM has been evaporated. It has been distilled off, and in fact only about maybe half a ml left. Now I am ready to actually terminate the experiment, terminate distillation. And so we turn the temperature off, and look at that, we have actually distilled off all the DCM from it. DCM has a very low boiling point, so it can be very easily distilled. You remove the thermometer adapter and the thermometer, and you remove the 3-way connector. Always disassemble from top to bottom. Okay, you remove the keck clamp, remove the distillation head, and remove the flask, round bottom flask, and you should actually be using a second clamp to fix the round bottom. It's a good idea to do that. We couldn't find a good clamp, so we had to use some makeshift arrangement. You remove the 3-way connector, and finally you remove this. Still it's hot, so not very hot, it's warm. So you want to make sure that you stopper it first, because remember, caffeine is volatile because it can sublime. Therefore, it's a good idea to stopper it. Stopper the flask to stop sublimation and the loss of product. Okay, you stopper it, and now you want to cool it. Cool it. It's a very good idea to cool it under running water. That's another way is to just wait, but the best way is to actually cool it quickly under running water. Okay, it's not a very hot flask because the temperature was not very high. So you basically use running water. You use a circular motion to cool it effectively. And once you are cooled, now you are basically ready to weigh and find out the yield. So we are back on the whiteboard. Mass of 100 ml flask that we use for distillation was 75.18 gram, and with the crude caffeine, the total mass of the flask and crude caffeine is 75.70 gram. And so we subtract the lower number from the higher number, you get 0.52 gram. That's crude caffeine. Now that's crude caffeine. Remember, we use 6.69 gram of tea leaves. How do we know that? Because the mass of tea leaves in one bag was 2.23 gram, and then we use 3 bags, and therefore the total mass of tea leaves is 6.69 gram. So out of 6.69 gram of tea leaves, we have 0.52 gram of crude caffeine divided by 6.69 multiplied by 100 will give you 7.8%. Now this is definitely crude caffeine. It has it may have the major caffeine, but it might have the other smaller components like theophylline and theobromine. Those are also xanthine derivatives. So the best way is to actually analyze it by either TLC using thin layer chromatography, or the sublimation, and we do not have time for sublimation.